Universe Sandbox has just released a preview version of its new graphics update that they've been working on forever. Today, we're gonna check out this new preview update that you can get right now. It's not like fully out yet, but you can get the preview version on Steam. And they've really, you can see, woo, the graphics. So like all the lighting and all the graphics in the game have been updated to have more realistic lighting, better collisions, and even new like UI stuff too. Let's go ahead and do this new tutorial that they're showing off the new features. The sun lets us see during the day. We can easily see it from Earth. In real life, the ultraviolet light from the sun can damage your eyes if you look directly at it. There it is. It's kind of dim. And it's so bright it hurts to look at. So why doesn't it look so bright right now? I was just wondering. Universe Sandbox automatically tones down the brightness of nearby stars as if you're wearing advanced space goggles so the light doesn't blind you. I see. This adjustment allows us to look at bright objects like the sun. Let's see how bright the sun would look to your eyes in space. Oh boy, here we go. Oh, okay, so they have a space goggles. So if you turn this off, it's gonna... Oh, whoa. So this is like more realistic what your eyes would see in space if you looked at the sun. Don't do that. The sun now appears blindingly bright. If you look at the sun in real life, the intensity of its light and the ultraviolet light it emits can damage your eyes. Thankfully, there's no ultraviolet light to damage your eyes in Universe Sandbox, but the universe still emits so much light that it saturates the human eye, making it appear larger than it physically is. The apparent increase in size is similar to looking at your phone's flashlight from close up. The light is so bright that it overwhelms your eyes and appears larger than the physical LED. Compare this to putting a piece of paper or your fingertip in front of it. Yeah, it's definitely a lot brighter. So new lighting, realistic lighting, I guess, with the space goggles thing. We're gonna try different collisions and stuff to see how the light comes off of it. And I guess we can try it realistically, like what our eyes would see versus the space goggles. And I also wanna try to make like a lava glowing planet to see the glowing planet. Because we could do that before, but now it'll look a lot cooler, I think. Let's see if going 5 times further away to Jupiter makes the sun easier to look at. Okay, let's do that. That's a little better, but the sun still looks incredibly bright even as far away as Jupiter. If you stared at the sun from Jupiter, you would still go blind. But the side of Jupiter that faces the sun is very dark. This is because as you move farther from a star or any light source, the amount of light emitted by that source spreads out over a larger area. 16 times less light in illuminating Jupiter than Earth. Interesting. So let's put on the space goggles. Oh, it also lights up the surface of planets. Okay. Jupiter is now lit up and the sun is a lot smaller. The sun is a bright light source in the solar system, but without stars, much of space is quite dark. Let's look at how we can light up a scenario where there are no stars. Ooh, here 100 random moons orbit Earth. Okay, so there's no star here. Look how dark it is. You can still see the glowing of the cities though. In reality, without a light source, we wouldn't be able to see Earth or any of the moons until they start colliding. Okay, this is the part I'm really excited for, to see collisions and how that makes everything glow. Turn on the helper light. Oh, okay. So this used to just be the default, but I guess they added it as a setting where if there's no light source, you can turn a helper light on to be able to see. So I'm hoping it all glows really cool. Ooh, okay. Check that out. That is so much better than it used to be. As the moons collide, the cooler ones glow red while the hotter ones glow white. Interesting. So they got like the colors and everything of the light accurate. Their temperature determines what colored light the moons or any hot object, including stars, emit. That's why hotter stars are blue. Space goggles filter out some of the emitted light to make sure it's not blinding. Let's see how bright these collisions really are. Okay. This is with the space goggles on, and look how bright it is. So if you were to actually see this happen with your eyes, this is what it would look like. You wouldn't be able to see anything. It's so bright. This is because the sun is much farther from Earth than we are from these moons, so more light from many collisions fills our vision, making them appear much brighter. So that was the little intro to the new update. And yeah, it definitely looks a lot better. Look at Earth, this glowing white ball. What's the temperature at? 5,000 Celsius. Yeah, I'm really excited for this. This is still in preview, so I wonder if we're gonna see any bugs or anything. But if you want to get this preview version, it's out for everyone on Steam. You just have to switch it to the beta. What I really wanted to try was a like slow motion collision with Earth. So let's go to Earth. And I want to like throw the moon at it, but we'll do it in slow motion. Okay, I did not mean to land on Earth. And we have the space goggles on. It doesn't really make a difference looking at Earth, but looking at the sun, yeah, okay. They should look a lot better. We go right into Africa. Nice. Okay. There's the first collision. Wow. Okay. Yeah, it definitely looks a lot better with the glowing stuff. It's like in previous updates, it felt like something could be bright, but that light wouldn't go and reflect off other objects. Let's turn off the space goggles though. That's crazy. If the moon hit Earth and you looked at it hitting Earth, you would be blinded immediately. That's crazy. This is very, very slow. It's only been maybe, okay, we're like 16 seconds a second. So it's been like, it took like a minute, maybe 2 minutes for it to, from first contact to be fully absorbed. And the entire surface starts fragmenting out. That's how much energy was transferred. Whoa, okay. That is with the space goggles. It's gonna be completely blinding. Everyone on Earth, would you go blind first or would you die first? And I'm pretty sure everyone's dead. It might say there's a chance of life, 0.2. Oh, look, they changed the life likelihood symbol to a little DNA thing. That's kind of cool. And Earth is definitely dead. Actually, does Earth recover from this? Let's see. Okay, it doesn't even look that bright. I wonder if we turn off the space goggles, what it looks like. Okay, so it looks like most of the lighting is gone. We have a bunch of clouds though, like cloud fragments. Earth does survive as a planet, but I'm pretty sure everyone's dead. Is it? What's wrong with the atmosphere now? Okay, I just did like, it's been like 100 years. Totally screwed up Earth. The equator's about 110 C. Yeah, you're still dead. No life's coming back for a while. Anyway, let's throw something smaller because that was really big. I want to see how bright like an asteroid, random asteroid. So if we had an asteroid collision, how bright would that be without space goggles? Where's it gonna hit? Oh, right here. Okay. It's about to enter the atmosphere. Okay, this is about real time. That's how fast this thing's going. A little bit. Okay, this is pretty much exactly real time. That is a very large asteroid if you actually think about the scale of like the countries and the Earth. Like this might be still pretty mass extinction. Okay, that's the moment of contact. Doesn't look too bright, but I wonder if it's completely blinding. It is. That's how bright a collision would be. How devastating is that to the Earth? Completely floods, or I don't even know. All the countries here are going to suffer. There's fragments going. Whoa, okay, look how bad that is. I just did a random asteroid. So like if a large asteroid hit Earth, yeah, that's not good. Fragments spread over the entire globe. That would be mass extinction event. Do we all go blind? Yeah, I think we do. Everyone goes blind on Earth. How did it affect the life likelihood? It's usually like 95, 92. It would be mass extinction. Lots of things would die. This is just the chance that there's any life. So obviously something's gonna survive, but it would be very, very, very bad. One last thing we're gonna try with this update. We can look at some of the other collisions they have built in. Oh wait, we should look at a supernova. The sun supernova in the solar system. Whoa! That definitely looks a lot better. The old supernova did not look that good. It's not even touching it yet. And look, Saturn is completely burning up. I bet a supernova is so bright, it'll definitely blind you. Like, oh, it's actually not as bright as I thought it would be. Is this actually what it would look like to your eyes? This is no space goggles. Could you actually see the supernova? Huh. Interesting. Every single object in the system is on fire. That's crazy. Earth exploding in real time. Okay, this is Earth just straight up exploding in real time. Okay, that looks kind of unrealistic. Whoa. We're gonna speed it up a little bit. Is this with space yeah, this is with the space goggles. It's that looks brighter than the sun, dude. Sphere of 1,000 planets. This is a PC stress test. I do want to see what this looks like with the new graphics. Oh, okay, the lag is crazy. Look at all of them glowing. I bet without space goggles, this is completely blinding. Yep. That's really cool though. All of these planets colliding. This looks so much better than it did before. Like, look at that. That's crazy. Oh, whoa. Did they kind of group together? Like, their mass combined? Oh, and this one's spinning its mass out. Look at that. That is so cool. Actually, that's insane. One last thing we're gonna try is to make a lava planet. Because in the past, we've been able to make lava planets, but they should look way cooler now. All right, it's going to be a random rocky planet between Mercury and the sun. So very, very close to the sun. Okay, that's it right now. It's even got like a kind of a glare coming off it. Bloom. It's heating up. This might just liquefy into lava if we let it sit long enough, because look at the temperature right here. It's 300 something. I think at around 500 it starts to glow. Okay, it actually looks like it's stabilizing. So to heat it up even more, let's put an atmosphere on it and get some greenhouse gases. Okay, we gave it an atmosphere. You can see that it's kind of got clouds now. We need to add more atmosphere layers. This is what we want. Okay, greenhouse effect should raise it by 1,000 degrees Celsius. Okay, that's insane. Yeah, it's heating up. Give it a minute and it should start glowing. Oh, there we go. Okay, that looks really cool. Yes. That is so cool. Okay, is that bright? How bright is that for real? Look how bright that is. That is so cool. This is way better. These graphics are so much better. Okay, don't look at the sun. That'll blind you. That is insane. We can even go down on the surface. You're actually like on the lava. That's so cool. Get it even hotter. Okay, now it's like just completely melting. How does this look with the goggles? Okay, it's not that bright with the goggles. Completely molten now. This is like a liquid planet. Is that stable temperature? Okay, it's still rising. Everyone, the average temperature is 1200 C. Your problem isn't even burning to death now. It's like greed. How is it greed? You're gonna just be blinded before you even reach the planet. Look at that though. That is so cool. If you guys have anything you want me to try with the new graphics, let me know in the comments. Thank you for watching. Happy New Year to everybody. I'll see you soon. Goodbye.